Hello. Okay. Welcome to the stream, and we are live once again to solve more creative problems today. Today we are going to solve, I think, two of the problems that we skipped in this pretty series. Okay. One of them being the traffic light problem, and the other is that sum of four values, that four sum. Okay. We'll solve those two and then call it a day, maybe. Yes. Okay. So the first problem is let's go about traffic light. Traffic lights. The first question is traffic lights. So what is this question saying? So there is a street of length x was positioned and position number 0 to x. Finally, there are no traffic. Initially, there are no traffic lights, but n sets of traffic lights are added to the street one after another. So we are given an empty road or maybe street, and there are no lights. So we are adding the lights based on the array. Okay, and our task is to calculate the length of the longest passage without traffic lights after each addition. So we are adding the poles and then returning the what is the maximum length of the unlighted passage or dark passage. Okay. X and n given as input, n is set of lights, and there is an n integers, p and position of each. Okay. So we have let's say this is the street. Let's say this is the street. Okay, and this position is 0 and this position is x. And I'm going to assume that this position is having a pole and this position is also having a pole, because in the constraints we are given that all the other pole positions are going to be between 0 to x. So there is not any position for so there will not be any for 0 or x. Okay, so we can safely assume that. Now when I put a pole, what actually happens, we are dividing this distance let's say it is a now. So we are dividing this distance into b and c, right? So how should we approach it? Let's take arbitrary state of the question. Okay, again we have the streets we have the lights. Let's say there is one light here, one light here, one light here, and we place one light here. So when we place this one light, let's say the distance between their immediate neighbors, its immediate neighbors was A, right? Then after placing that light, we are dividing it into B and C. So how do we keep track of this? How do we keep track of positions and the distance? So for position we can use set actually. Okay, for position we can use set. So let's say this is 0, this is 10, this is, let's say, 5, 2, 5, and this is 9, and we're putting it at 8. So if we had a set, so all the position will be stored in there. Okay, this set, this is for lights. And before inserting any pole, we will look for neighbors, right? So we can just find the neighbors by using upper bound, right? So 8's upper bound is 9, so this the pointer to this and just before this will be the neighbor. Okay, so this distance is going to be changed, and you also need to keep track of the distance, right? So we will have a multi-set, or you can have a map. Yes, both will work. Both will work. We can use a map. So we have a map. Okay, so in this map what we will store is, we will store all the distances as we keep adding the lights. Okay, so for this arbitrary state, what we will do, we will find this distance. How? We have the iterator to it. Well, let's say this is I2, this is I1, then we will find this I2 minus I1 and then erase it. Okay, we will erase it, or erase it, and then we have and then we have to add the new distances as well, na? So we will add mp.insert, or instead of insert what can do is mp, and whatever position we are adding, so it is position minus let's say I1 plus plus, and also I2 minus position plus plus, and we will add the position in the lights also. So lights dot insert position, and for getting the answer we can just do this mp dot end, and whatever iterator it is pointing to it, we will just decrement it, and then this is the answer. Okay, so we are just simulating it, nothing else. The using sets and map, we can keep track of the light position, traffic light position, and the distances between them efficiently, so it will work. Let's implement this. have position we'll have a set position lights position. We'll have a map. This is the distance. Okay, then we'll iterate in the traffic lights. And before that, lights pause dot insert, we're going to insert 0, and lights pause dot insert, what is x? X is the length, huh? So insert x, and distance dot insert distance dot x plus plus. Okay, so we are done with this, and we will take the input of the light position, traffic light position that we are going to insert, and once we have that, we need to find what? We need to find the neighbors. So let's say IT2 is MP, not MP. Lights pause dot upper bound this position, and we will have another IT1 is IT2 and IT1 minus minus. Okay, so we have this, then we'll find the distance. So dist dot so we will do what? I will do MP star IT2 minus star IT1 minus minus, and if MP this thing double equal to 0, and np dot erase this thing. Now we're going to now that we have deleted that distance, we will put new distances, right? So MP star IT2 minus pause plus plus MP pause minus star IT1 plus plus. I will also insert it into the lights, the position. Then our answer is going to be no, not this. Then we have the answer as this is our answer. Is there anything that can? Yes. MP dust. MP. Oh, no. And change it to dust. Oh, sorry. 2 and 8. IT2, huh? The fuck? Okay. Five, 3 and 2. What do we use a multi-set instead of map? Eh? Why? Wait a minute. 1 second. Oh, wait. I mean, I am going to comment these two and comment these two. Okay. So we can use both multiset or map, but just you have to keep in mind that for map you have to do this, okay, instead of directly doing this, because it will delete the entire entry, not the count of it. And multiset, I think it will delete the count first, without us having to do all this manual labor. So multiset is quite good in that regard, so I think it will work. Let's see. I will try to submit this, and also it is like second to last stream to this whole series. So actually we have come quite far with this, so yeah, I'm actually very proud of myself for this, for not abandoning this series in the mid. So, now the sum of 4 values. This thing, unlike so we can actually do a 4 sum using a 3 sum plus a single number, but it will be not easy to explain. I think it will be hard to explain. Other than that, or this and this idea that I'm about to share with you is not something that came to me. I have searched for it, how to solve this in easy way. Okay, so I'll admit that. Select. No, I want to crop this. How do I crop this? Shapes and lines. Okay, we will solve this problem and then wrap the stream up. Okay. Yes, this is sum of 4 values. Sum of 4 values. Okay. Now, sum of 4 values. We need to find 4 values that sum up to this given value. Okay. Position basically. So let's say x is equal to a plus b plus c plus d, right? So we need to find all their positions and then return the position for all the 4 numbers that sum up to this value. So how do we go about it? So how are we going to solve this problem? How to think about it? How should we approach it? Okay, so we can do brute force, of course. We can do n to the power 4 loop. Okay, but it will not work here. If it was 100 or maybe 10, then maybe we could do, but it is 1000, so we have to do it within n square. Okay, and 3 sum can be done using n log n, and if we try to add another loop there, n square log n is also possible, so we can do it that way. Yes, we can do it that way. Actually, we should try to do it that way. Maybe we'll find a solution. So we'll sort it with their position, of course. So it will be 1, 2, 2, 3, 3, 3, 5, 8. We will keep one index here, one here, and then try to find the other 2 using binary search here. So it will take n square for this and log n for this, and given the constraints of n, which is like 1 to 10 to the power 1 to 1000 should be 10 to the power 6, and log n of 10 to the power 6 is what? 10 to the power 6 log n is what? Log 1 is 6. 19. So 20. So into 10 basically. Into 20. So it will work. We have another solution though. So that solution includes pairing the elements up, and then we will find the pair sum. Okay, so what we are going to do is we have this array 3 2 5 8 1 3 2 3. Okay, so what we are going to do is we will store the pair sum in a map. Okay, we will have a map, we will store the pair sum. Let's say 3 and 2, which is 5, so we will store its position as well, and we will do it for all the other pairs. Okay, and then what we will do, we will iterate again and then find if I can and then try to find in the map if I can find x minus whatever these two numbers are. So let's say this is value vi vg. So if I can find this number in the map having this indices different from I and j, so we'll make sure of that. So if I can do that, then that means I have found my solution. I will print it and then return it, right? For example, in this case itself, there will be a lot of this. So let me take a simple scenario. So let's say we have 5 1 3 2 4, and I want to find sum 10. So what are the pairs that we can have? So it will be 6 1 and 2. Okay, it will be 8 1 and 3. It will be 7 1 and 4. It will be 9 1 and 5. It will be 4 1 sorry 2 and what 3. It will be 5 3 and oh no sorry it will be 3 2 and 4. It will be 5 2 and 5, and then we have 5 3 and 4, and we can include this in here only. Okay, and then we have 7 with 3 and 5. You can also include this in there. We have 6 4 and 5. You can also include this there. Okay, we'll include that there. So if I want to find the sum 10, I'm going to iterate in this map, or maybe in pairs in this only, in this array only. So I found the sum 5 and 1, so it is equal to 6. So I will check if I can find a 4. So yes, I can find a 4, and their indexes are different. No, their indexes are not different, so I will discard it. I will not use it. I find another 4. If there is another 4, I will take it. There is none, so I will skip to the next pair. Let's say 1 and 3. So 1 and 3, that is 2 and 3. Okay, 2 and 3. This one I will start with 4 here, and I'll try to find a 6 that I can have, and I can have this 6, but the indices are overlapping, so I will discard it. but this 6 I can take. So yes, I can take 2, 3, 4, 5 indexes to make the sum 10, and in this way we can solve the problem. So we have to make sure that there is no overlap though. So we will not directly add all pairs in the map. We will keep adding it while we are while we are trying to find the solution. So instead of adding all this in at once, what we will do, we will start from here. Our I will be here, okay, our j will be here, and I will go from here to the last one. Okay, j will also go from here to the last one. I minus 1, j is basically I minus 1. Okay, it will go till 0. So we are going to find, if we are going to see if I can find ith and jth sum counterpart for it in the map. If I can, then I will just print all 4 values, otherwise not. And after that, what we will do, we will add values in the map. So I will start from j and no, I will start from I plus 1. Okay, the pair that I've already tried to find the answer for. So here in imaginary values, so let's say our j is here right now and I is here. Okay, so after finding for their counterpart in the map, we will start from here, and then this pair will be added in the map, and also this pair will be added in the map. So 325 and 336 with this combination will be added, and since we are keeping the pointers separate, then there is no chance of overlap also. So this way we can solve it. Okay, it will take n square only. The 10 colon next will be n square only. Okay, since this is the I and the inner loop is j going from I minus 1 to 0, so n square. So we have two algorithms. First is n square log n, and the other is n square. Okay, so I'll try solving using both. But the three-sum problem will take a lot of time to implement. But you can do that. Yes, I will not do it. You can do that. I will not do it. Okay, now that we have this, we need a map. We need a map. Should I use a multiset? I don't really use multiset often, so let's get in the habit of using it. So I'll call it multiset. Set? No. We'll say pair. Yes, pair. And so we have this. We have target, which is nothing but x minus our values, and if pr dot count, pr dot find this target. Okay, we cannot use multiset, we need pair now. So map int pi mp pi no, mp. We have found a pair, so we will and we'll set a flag, or we'll just return from it. Cout impossible. Okay, after this is done, we'll do j from I plus 1 to n. We will put the values in the map, pairs in the map. Si, j. Okay. The fuck. Five, 4, 6, 8. Is it correct? 5, 8, 1, 9, 12, 15. Yes, correct. This is correct. Okay, so we're done with the questions. There is one problem reading books that we'll do in the next week. Yes, we'll do in the next week. So for today, that is all, and yes, in the next stream, that will be our last video for this series. So I hope you join that as well. Yeah. Yes. We'll meet in the next time. And maybe yes, next stream might not happen on Monday or Tuesday because I have a training scheduled up. So maybe Wednesday. Yeah, Wednesday should work. Yes, we'll meet Wednesday then. Till then, take care of